All right, so our last unit for Algebra 2 is a unit on trig. There are lots of topics about trig. We are just going to touch the little bit of the surface, okay? But it will get you some background on it before next year when you take pre-calc, to give you an idea of, so it's not brand new next year, okay? When we've worked with angles before in geometry, you always measured them in what unit? In degrees, okay? We have a different method of measuring them called radians. And radians, we still use degrees a little bit in pre-calc, but we use radians quite a bit more. So I do want you to see what that looks like. Okay, so a typical angle, if we put it in standard position, the vertex would be at the origin. Where in our picture is the vertex? Okay, where the rays intersect? Okay, this is my vertex. The initial side lies along the positive x-axis. So this would be the initial side. This piece up here, the second ray, is called the terminal side. And if you look at the way the angle has been measured, if you look at the little blue arc and the direction it's going, we are starting from the initial side and measuring to the terminal side. But the way it's drawn here, we are measuring in a counterclockwise direction. Okay? So when we measure counterclockwise, it's a positive angle. Okay? If we measure clockwise, it's going to be a negative one. All right, so if you look at your picture, this should be familiar to you. We have quadrant 1 up here, quadrant 2, quadrant 3, quadrant 4. Those are being measured in a counterclockwise direction, right? That's why the numbering goes that way. Your angles, when they are in standard position, will always have the initial side here on the positive x-axis. So every angle is going to start there. And then the terminal side opens up. If it opens in a positive direction here, we're going counterclockwise, and this is our terminal side. Okay? But we can get to that same terminal side going in a negative direction. That's what the little blue curve is. Okay? So we can measure this in a positive direction, we can measure it in a negative direction, still get to the same terminal side. The quadrant an angle lies in is defined by the terminal side. All angles are going to have the initial side on the positive x-axis. So it's where that stops opening up. Okay, where that last side, the terminal side is going to tell you what quadrant we would call that angle. If the terminal side lies on the x-axis, the angle is called a quadrantal angle. Quadrantal. Okay, so it's not in a quadrant, it's in between two quadrants. Okay. Questions on any of the terminology? All right, so you've been measuring things in degrees, and if we went all the way around the circle, okay, so from here all the way around to there, how many degrees would that be? 360. So one rotation is equal to 360 degrees. Typically we don't write the word degrees, we just use the little degree symbol, okay? It is critical when you're talking about angles that you define it, is this degrees or is this radians? There is no symbol for radians. So if you write 360 without the little degree sign by it, it means 360 radians, which is completely different than 360 degrees. Okay? So if you are meaning degrees, you have to have the degree symbol on there. Okay? Or write the word degrees next to it. Okay, so these are angles that you should know already. We've got right angles that are 90 degrees. Acute angles are between 0 and 90. Obtuse is bigger than 90, but not quite to 180. And if you actually get all the way across to 180, you are at a straight angle. Yes? Those are familiar to you? Okay. So, if we were to measure in radians, I want you to pick a circle in your packet. Just pick any picture of a circle that you see. Okay? Think about how big the radius of that circle is. And pretend that you are measuring that radius with a piece of string. Okay? Everybody has that visualized? Okay. Now, start that string at 0 degrees. Okay, put one end of the string there. How many of those, if we curved it around the outside of the circle, how many of those string lengths that measure the radius would fit all the way around your circle? I'm going to pause the recording. I want you guys to talk about that. All right, so we just talked about your predictions. Most of you are saying somewhere around 6. I want you to think of a circle, okay? What's the formula we have for the circumference of a circle? Yes? So, R stands for radius. So your circumference is how many of these R's? What's our formula say? Circumference is found by taking R and multiplying it by 2 pi. So there should be 2 pi of these pieces to make up the circle. Yes? Well, how big is 2 pi? 6.28. So there are 6.28 of these pieces of string that would make your circumference. Yes? Doesn't matter how big the radius is, it's always going to be 6.28 of them. Does that make sense? Okay. So when we switch to measuring in radians instead of degrees, we have to understand that concept of a radian. 1 radian is the measure of the central angle of a circle. Okay, central angle meaning the vertex is at the center of the circle. Right? That intercepts an arc equal in length to the radius of the circle. Okay, so again, if we measure this length, okay, that's 1 radius. If I curve that around the outside, okay, 1 radius, it creates an angle here that we refer to as 1 radian. Okay? Yes? To measure an angle in radians, you are going to take the length of the arc, the intercepted arc, and divide it by the radius. So what happens, we've got, in this picture up here, we've got 1 radian, right? But our arc could be bigger than that. So let's say we have an arc from here out to here, right? That's bigger than 1 radian, but it seems like less than 2 radians, right? How do we figure out what that is? And we simply take the arc length divided by the radius. Okay? Have you seen this symbol before? Yes. What is it called? Theta. Theta. There's different angles, symbols. They're all Greek letters. So angles could be measured in theta. You could have alpha, beta. They're all Greek letters. Okay? There's omega. Looks kind of like a W. Okay? So don't get worried about that symbol. It just stands for an angle. Okay? So, we talked about going all the way around our circle and that being 360 degrees, right? If we rotated that angle all the way around. So how many radians would that be? I'm hearing 6.28. What's another way of saying that? 2 pi. So we say 1 rotation is 2 pi radians. Okay? All right, it says a central angle, theta, in a circle of radius 6 intercepts an arc of length 15 inches. What is the radian measure of theta? Okay, so we have a circle. has a radius of 6, and it intercepts an arc, the central angle theta, intercepts an arc that's 15 inches. Yes? So, are we bigger than 1 radian? Yes? Are we bigger than 2 radians? If a radius is 6, right, a radian would have an arc length of 6. So are we bigger than 2? Are we bigger than 3? No, somewhere between 2 and 3. Yes? Okay. So theta is found by taking the arc length divided by the radius. So 15 divided by 6 gets us what? 2 point what? So does that make sense if you're visualizing, here's 1 radian, here's a 2nd radian, here's a 3rd radian? 3 radians would mean an arc of 18, right? 3 sixes. So 2.5 makes sense. Now, there is no symbol for radians. At this point, I would like you to actually write the word radians with that, so you're keeping it in your mind what you're talking about here. Okay? Questions so far? All right, so we can easily convert between degrees and radians. When you get to pre-calc, there's going to be some special angles that we expect you to know in radians, okay? But if you have some weird angle, you can always convert it. What's the conversion from inches to feet? 12 inches equals 1 foot. So I can use a conversion factor, right? 12 inches equals 1 foot, 12 over 1, and I can convert things. If I want to convert the other direction, I can have 1 over 12, right? I can flip-flop it depending on what I'm trying to convert into. Well, the same thing works for degrees and radians. We said 360 degrees was the same as 2 pi radians. That means that 180 would be equal to 1 pi. Does that make sense? If my whole circle, going from here all the way around, is 2 pi, then going halfway would be 1 pi. Yes? So this is 0, and if we go all the way back, that would be 2 pi. So if we want to get radians and we had degrees, we need to get rid of degrees. That means we're going to have degrees on the bottom. If we want degrees, we're trying to get rid of radians, so we need pi radians on the bottom. Okay? All right. We're going to start with converting angles into radians. So 30 degrees, what are we going to have to multiply by? Check your paper. Did you put the degree symbols on there? It makes a difference. All right. So can we reduce 30 and 180? 30 goes into 180. How many times? 6. Now, the degree symbols are going to drop out, right? We have degrees on top, degrees on the bottom. So all we have left is pi over 6. So my answer here would be pi over 6 radians. Okay. How about 90 degrees? Ninety goes into 180 how many times? So we end up with pi over 2. Okay. Now, picture 90 degrees on your circle. Okay. If this is my initial side, where would 90 degrees be? Straight vertical? Yes? Well, if this is pi all the way over to here, what would this be? Half of that? So does it make sense that 90 degrees is half of pi? Okay. How about negative 138? Sorry, 135. What goes into 135 and 180? Something bigger than 5. Something bigger than 15. 45. 45 goes into both. Okay, so how many times does 45 go in here to 135? How many times? 3 times? Okay, so this is going to be -3. This is going to be 4. So we end up with -3 pi over 4. All right, going the other direction. We have pi over 4 radians. And we want to get that into degrees. So what are we going to multiply by? Okay. So what drops out? Pi. So pi radians has gone there, pi radians has gone there. Yes? So we have 180 divided by 4, which is 45 degrees. Okay, now go back to our picture here. This was 90 degrees, right? We said that was pi over 2. 45 degrees would be halfway in between there. Does it make sense that that's pi over 4? Okay. All right, you guys do the next two. All right, so we start with -5 pi over 3. Those are radians. We're going to multiply by 180 degrees over pi radians. So, do the pi's still drop out? Okay. Can we reduce the 3 and the 180? 3 goes into 180 60 times. 60 times -5. Can I leave my answer just like that? I need that degree symbol. Okay. Now, the last one here might be a little confusing because there's no pi in there. Okay? But when we write pi, what number are we really meaning? So if I have pi radians, it's 3.14 radians. Yes? Those are equal. Okay, so we have 2 radians. We want to convert it to degrees, so we have to divide by pi. Okay. That gives us 360 divided by pi. This was in radians. This was in radians. So that unit would drop out. We just have degrees left. Take 360 and divide it by pi. What do we get for a decimal? Say it again. All right. So 2 radians would be about 114.6 degrees. Yes? Because 3 radians is how far? Almost halfway around your circle, right? 3.14 would be halfway around your circle. Okay? Questions at all about converting? Back or forth? All right, we're going to look at drawing angles in standard position, being able to place them, that terminal side in the correct location. Okay? We're going to start out just with some real basic radian angles. Note it says here, you will be expected to draw angles in radians without first converting them. So I don't want you to look at the angle in radians, convert it to degrees so that you can draw it, and then go back to radians. Okay? You got to start thinking in terms of radians. So what did we say for 2 pi? We've already talked about that one. It's the same as 360 degrees, right? But instead of thinking degrees, I want you to start thinking 2 pi. That's 1 full rotation. Yes? So we would write our initial side here. We would show that we're spinning all the way around and getting back to where we started. Okay? All the way around is 2 pi radians. 1 pi would be how far? Halfway around. So we're going to there. Yes? How about pi over 2? Okay, that's our 90-degree one. Again, think in terms of halfway to pi. Yes? Okay. So what about 3 pi over 2? Draw where that would land. 3 pi over 2, 3 halves of pi. 3 halves is what number? 1.5. We need 1.5 pi's, right? What quadrant are we going to be in? That's a trick question. In between 3 and 4, right? This is a quadrantal angle. We need to go 1.5 pi's. This was a half a pi. This was a full pi. This would be another half. Now notice on all of these we went in a counterclockwise direction, right? Because those were positive angles. Most of the time when you're dealing with radians, you are going to have fractions. Okay? Pi over 6, pi over 2, pi over 3, pi over 4, things like that. You want to use the denominator to help you visualize how you're going to split that up into chunks. Okay? So, if the denominator is 3, we want to think of taking 1 pi, which is half of a circle, yes? And we want to split it into chunks that are 3s. So take that top half of our circle and split it into 3 chunks. We'd have one about here, we'd have another one about there, and then we'd have our third one. So this is 1, 2, 3 pieces. Does that make sense? So we said all the way to here is pi, and we're starting at 0. So what would this mark be? One-third pi. Pi over 3. This one would be, and you can write it 2/3 pi like that. You can write 2 pi divided by 3. Doesn't matter. And our last one out here would be pi, because it's 3/3, right? We've had 3 of our 3 pieces. Could we divide the bottom into 3s just as well? Yeah. All right. How about if the denominator is 4? So now we want to split this top half into 4 chunks. So here's splitting it into 2, and then each of these quadrants would have to be split into half again. So this is 0. This is pi over 4. This is 2/4, right, which we would reduce to 1/2. This would be 3/4. And this would be 4/4, which is a full pi. All right, go ahead and try the third one there. What if your denominator's in 6s? All right, if we split into 6s, that means each of our thirds from our first picture would have to be cut in half. Yes? So we need, in quadrant 1, we need 3 pieces. In quadrant 2, we need 3 pieces. All right, so this is 0. This would be pi over 6. This would be 2/6 or 1/3, 3/6 or 1/2, 4/6 or 2/3, 5/6, and pi. Does that make sense? All right, so you are going to look at the denominator to help you figure out how to split it up. Our first one says we want 4ths, right? We want pi over 4. So picture splitting the top half into 4 pieces. And we just need one of them. So if I want an angle that's pi over 4, this right here is going to be my angle out to here. Okay, so this would be theta. Now if I want 5/4, where's that going to land me? There's 1/4, 2/4, 3/4, 4/4, 5/4. Yes, 5/4 is bigger than 1. So we're past our 180 mark. So from here all the way to here, would be an angle that is 5 pi over 4. Is that making sense or not? Okay. How about C? How are we going to split it up? Into threes, right? The top half is going to have 3 pieces. Okay, so from here, here's 1/3, 2/3, 3/3. But what kind of angle is this? If it's negative, I have to go which way? I have to go the other way. So think of splitting the bottom half. Oops. Adjust that a little bit. So we are starting at the x-axis. We're going to go negative, so clockwise rotation down to the second marking. Yes? So that angle would be negative 2 pi over 3. All right, go ahead and figure out the last one. All right, splitting into sixes. 1, 2, 3, 4, 5, 6. Yes? We need 5 of those. Which direction are we going to rotate? Counterclockwise. We need the 5th mark, 5 of those 6 pieces. So we're going to go to here. Okay. We're going to stop here for today. The homework package you're going to get, remember, is just some book pages from a different book. I have copied the sections you need. You are going to do the circled ones. Through number 55 on the Trig -1 sheet. That doesn't mean you have 55 questions. It means the last circled one is number 55. Okay? You'll see when I hand it out. There's not 55 questions. Don't panic. Okay? But you are going to need to keep your packet, so put your answers on a different sheet that you can turn in each day. Okay?